Okay, so what about something like this right here? What are we going to do with an equation like that? We could call this solving a radical equation or solving an equation with radicals. We've never seen anything like that before, though, where we've got an x that's inside a square root. But you probably could figure out what to do. If you just thought about this and used your intuition, you would probably know what to do. So at this point, everybody close up your Chromebooks enough that they're not going to distract you. You'll get a chance to work on a few of these at the end. But you really need to be with me now. Where time is short. I'm going to make this really easy and understandable for you. It's not hard, but there's some steps you got to learn to follow. So what do you think, Casey? What are we going to do on this one? If I want to solve for x. Suggestions. How would you reverse PEMDAS to isolate x here? What would you probably do first? Subtract 11. Okay, so first we'd want to add subtract to both sides. So subtract 11. And that would give us the square root of negative 3x minus 4 equals, what, 3? Okay, now what? What do you think?
Reverse the square root.
Reverse, okay, yeah, how would you undo a square root? Square it. Yeah, we'll square both sides, right? So what if we were to take both sides of the equation and square each side? Well, the square is going to undo the square root, right? And then I'm going to end up with, on the left side, negative 3x minus 4, and on the right side, I'm going to get 9. And now from there on out, it's looking a little easier, maybe. Now what? So add 4, and then what? Divide by negative 3. So if I add 4, I'm going to get negative 3x equals, what, 13? Yeah. Okay, and then what from there? Divide by negative 3. So I'd end up with x equals negative 13 thirds would be my answer. But here's the thing you got to be careful of. If you ever take both sides of an equation to an even power, you might introduce what's called extraneous solutions. Okay, so extraneous solutions would be like extra false solutions, right? You don't have to worry about that if you take both sides to an odd power, but because we're taking both sides to the power 2, that's even, we have to always check our answers to see if they work. And you probably should anyway to see if it works, but in this case you have to, because it might turn out that this really isn't a solution to the original equation. So we'd go back up to the original equation and we'd try this out and see what happens. So anyway, so if we go up and try this, let's see what we get. Thank you. Okay, so if we try negative 13 thirds for x, let's see what happens. So I'm going to plug in x equals negative 13 thirds. I'm going to get the square root of negative 3 times negative 13 thirds minus 4 plus 11. We need to see if that's equal to 14, right? Well, what's that give us? Well, if I multiply negative 3, same as negative 3 over 1, times 13 thirds, what do we get? Negative times negative is positive. So I could do this, right? That becomes positive, that becomes positive. Can I cancel anything? The 3's, yeah, the 3 over 3 becomes 1 over 1.
So you just get 13.
I just get 13. So 13 minus 4 is what?
9.
9, okay, and
Square root of 9 is 3.
square root of 9 is 3.
3 plus 11 is
Okay.
13. Your answer works.
Good, so that would become 3 plus 11 equals 14, so it checks, doesn't it? Right, it worked. It worked in the original equation, and so then, yes, that is a solution. We checked it out, right? Okay, good. All right, what do you suppose we would do in a case like this? Oh, if we go back real quick, before we move forward again, I mean, we could summarize what we did here. When we have an equation that involves at least one radical, right? What we did was we isolated the radical, and then we took both sides to whatever power we needed to get rid of the radical, right? So let's use that same strategy again here. What am I going to do this time?
Square both sides.
Okay, but before I square both sides, I could maybe,
Multiply or divide.
yeah, multiply or divide, right? So how would I, for example, get rid of the 3?
Multiply by 3.
Okay, I could multiply each side by 3. So those cancel, right? And that's going to give me a 6 on this side. So then I've got negative 2 times the square root of negative 3x minus 18 equals 6.
That 2. Or is it like?
It's a 2. Yeah, that's 2. Negative 2. So now what?
Divide by negative.
Divide by negative 2, how about? Good idea. So those cancel, and I get square root of negative 3x minus 18 equals negative 3. Okay, we isolated the radical. Yes, ma'am.
Where did you get the negative 2 as well?
I just divided each side by
Oh, okay.
negative 2 to get. Because remember what I'm trying to do here. My goal was I wanted to isolate the radical, right? Which I did. It's isolated. So how do I undo a square root?
Or square.
Square each side. Okay, so if we square both sides. Now, what's wrong with what I did on the right side there?
You square the.
Got to put it in parentheses. Remember, if I square a negative, I always have to put it in parentheses. So on the right side, we get negative 3x minus 18. On the left side, I mean, on the right side, we get
9.
positive 9. So what are the 2 steps in order to solve for x?
Add 18.
Add 18, and then
27.
Then- divide by negative 3.
And you get negative 9.
Okay, so negative 3x equals 27. If I divide by negative 3, x equals what?
Negative 9.
Negative 9. Okay, so let's check it and see. If I plug negative 9 back into the original, let's see what we get. So that gives me negative 2/3. I'll just put the negative 2/3 out front, times the square root of negative 3 times negative 9 minus 18. And we want to know, does that equal 2? Okay. So negative 3 times negative 9 is
27.
27, minus 18 gives us
9.
9. So I get negative 2/3 times the square root of 9. Is that equal to 2? Well, that's going to give me, that's just 3, isn't it? Negative 2/3 times 3 is negative 2, right? Is negative 2 equal to 2?
Yeah.
It's not. And so what's that tell us?
9. Negative 9 don't work.
It's
Not a solution. Yeah. So there is no solution.
There's none. No solution.
No solution. So if we were to graph these two functions, that function on the left side and then the line y equals 2, they would never cross. Okay? There's no value of x that could ever make that true. Okay? So there's a case where when we squared both sides, it gave us an extraneous solution, but we checked it and we saw that it was extraneous. Okay, what do you think I would do in a problem like this? This looks pretty hard, but it's actually really simple.
You do the same thing, just cube both sides.
Yeah. We're supposed to isolate the radical, right? Well, they're both isolated. right? So I can just cube both sides this time. If I cube both sides, what do I get on the left side? Okay, negative 10x plus 1 on the right side. Okay, then what? Which side should I push the x's to?
10. What?
No?
Right.
The right. How come?
Because the 10 is bigger than the 8.
Okay, well, negative 8 is greater than negative 10. We want to push the x's where we'll have a positive number. It'll work either way, but it's just better form. There's less chance of making a mistake. So we'll add 10x to both sides, right? Those cancel, which means on the right side, we're going to get 2x. Where should we push the numbers then? Left. Okay, so we'll subtract 9. 1 minus 9 is negative 8. So what's x equal to? Okay, do I need to check this one? I do not. How come? Because I took both sides to an odd power, right? So we know that we're okay this time. We still could check it to see if we did our algebra right. But if we, assuming we did our algebra correctly, that has to be the right answer. Okay? They can't be extraneous. You don't introduce extraneous solutions when you take both sides to an odd power. Okay, what if, hypothetically, real quick here, what if I'll put these up on Moodle today. I'll put up the notes and everything. Okay. Okay, let's say hypothetically, what if I had a 2 out in front of the radical on that side? Okay, what could I do? Does that make it a ton harder?
No, you just gotta divide it by 2.
Okay, but if I divide it by 2, I'm going to get the 2 on this side outside of the radical. So no matter what I can do here, do you see that this is kind of like a game of whack-a-mole? No matter what you do, I'm never going to be able to isolate both of these radicals at the same time, right?
So you isolate one, solve it, and then isolate the other.
Okay, good. So what we could do is we could make sure that one of them is isolated, right? And then I'll still cube both sides. But in this case, it's still going to be okay. Because if I cube both sides, watch what happens. If I cube the right side, that's pretty simple. What do we get on the right side?
Just negative x plus 9. Or
Negative 8x plus 9. Good, just like we did before. Now on the left side, let's not make this harder than it is. If I've got, so what if I did this? What if I said, let's take the quantity 2x cubed? What's that going to be?
8x.
It's going to be 8x cubed, right? Because when we take a product to a power, we distribute the exponent to both factors, right? So we're just going to do the same thing here. How many factors are there on the left side? I've got a 2 times a cube root, right? Still got 2 factors. So I could just distribute that 3 to the 2 and to the radical. And what's it going to give me then? 2 cubed is what?
8.
8. And then a cube root cubed just undoes the cube root. Right? So I'm not even going to go any further with that, but you see that that's no big deal. Just distribute the 8 and then solve for x, right?
Right.
Okay, no biggie. That works. Okay, what about one like this? You know, so, Justin already gave us a good strategy for this. What are you going to say? Apply what you said last time to this. What would I do?
What did I say last time?
Well, you said isolate one, and
So you
You know.
isolate the left side.
so which is already isolated, right? Now, what would I do to both sides to undo the radical? Because that's what I have to do. To be able to solve this equation, I gotta get rid of the radical. Yeah, we just square both sides. Okay, so
And
if
then
we
you get
square
x
both
squared
sides.
Plus 25 on one side.
Okay, but hold on now. X plus 5 quantity squared is not x squared plus 25, right? Because remember what it means is x plus 5 times x plus 5, right?
So then you put it twice.
So you would. So you have an option here, right? So we have an option here. On the right side, we could either just, if you forget the pattern, that's fine. You could just write x plus 5 squared x plus 5 times x plus 5 and distribute and add like terms. It's going to work. But there is a shortcut on this. What's our pattern? It's useful. If we have a plus b squared, what's the pattern for expanding that? Do you remember?
Isn't it, a plus, wait,
A
a squared
squared.
plus b squared?
Plus, no, 2ab plus b squared, okay? So we can use that. If we forget it, don't worry. I mean, then just multiply x plus 5 times x plus 5 and it's gonna work, right? But in this case, a would be like x, right? So there's our a plus b squared equals a squared plus 2ab plus b squared, right? Okay? So what's a squared gonna be for us?
A squared.
X squared. Okay, good. So we end up with x squared plus what's 2ab gonna be? 2 times x times 5 is what? 10x. And then b squared is gonna be what? 25. Okay, make sense?
Yeah.
On the left side, we get rid of the radical, right? So we get negative 5x minus 25. And sure, that looks, like you got some work to do, but that's stuff we can do. That's a problem you did way back in module 6, right? We're just gonna solve a quadratic equation. It's quadratic because I've got x squareds and x's, right? Well, how do I solve a quadratic equation? First, what do I have to do to it? Put it in what form?
Quadratic.
What do we call it? Standard form, which means I'm setting it equal to
Zero.
0. Good. Okay, so we'll add the left side over. So I'm going to add 5x to both sides. Okay, and then that's going to give me 0 on the left side. On the right side, I'm just going to get x squared
15x.
plus 15x plus 50. Good. And so that's just when I have a quadratic. Hey, everybody focus, please. Everybody turn around, face front. Thank you very much. Okay, so if we rewrite this, let's put the 0 on the right. This ought to look pretty familiar.
Quadratic equation.
So yeah, what could I do? What are my options? I could use the quadratic equation. If I have a quadratic equation in standard form, I could use the quadratic formula, you mean, right? Could use the quadratic formula. But could I do something easier? Magic numbers. What numbers multiply to 50 and add to 15?
10 and 5.
10 and 5. Okay, so we could factor this into x plus 10 times x plus 5. What's the solution? First solution?
Cool.
Okay, we done?
Yeah.
No. What do we have to do? Oh, we got to check them, right? Because we squared both sides, so we got to check them.
Will you ever have one that like one of them works and the other one doesn't?
Yeah. In fact, this one could be, honestly, this has an equal chance of being one where neither of them work, or only one works, or they both work. It's 1 in 3 chance, based on how I wrote these questions. Okay, so let's try these then. If we try negative 10, see if it works. If I plug negative 10 in, I'm going to get right, so I'm going to get the square root of 50 minus 25 is what? Negative 5 times negative 10 is 50, right?
Yeah.
Minus 25, square root of 25. Is that equal to negative 10 plus 5? We get 5 equals negative 5, not true. Not good. That one doesn't work. Okay, let's try negative 5. If I plug in negative 5, I'm going to get square root of 25 minus 25. What's that?
0.
Square root of 0. Is that equal to negative 5 plus 5?
Yes.
It is. 0 equals 0. So that one checks out, right? But the other one didn't. So -5 would be a solution. The other one was extraneous. Okay, make sense?
Yeah.
All right, pull up 10-3, do at least 2 problems from part 1.
10-3.
11, part 11.
Do I need to pick up that packet today?
Yes, you do. I'll give it to you right now.
Anything else?
Add that back in.
Yes. Is anybody gonna be gone tomorrow?
I don't know yet.
There you go.
You'll be gone tomorrow. You gotta go all the way to town.
Well, the stuff that's online. Yeah. But that's the one you can start working on, just paper and pencil. Well, because I wanted to, I don't know, I thought that was easier to go over like that. Otherwise, it had to be down there. Anybody else?
Mr. White?
Yeah.
Am I gonna take this test?
You're a sophomore, right?
Yeah.
So you're not gonna take it. You'll take it next year.
So,
I don't think that you can't take it this year, but they'll let you take it next year.
so even though I passed the essential skills, I still have to take the SBAC?
Yes. Yeah.
Obviously not.
No, okay, hey, listen. So the essential skills will be like an insurance policy. Essential
Yeah.
skills meets your graduation requirement, right? But passing the SBAC is a lot better than passing essential skills.
What if I don't pass it? Well, I got it
I
either.
mean, it's not gonna ruin your life, but if you'd rather pass it than not pass it. Then I'm gonna have you do the essential skills again. And I'll go through stuff with you. You'll get it. Who needs one of these? Who's not gonna be here tomorrow? Anybody else?
So you're
Everybody
just
else
gonna
is
run
here?
out the whole piece?
You're talking about tomorrow?
Yeah.
Don't you fall back on work samples though, if you don't have?
Yeah, and we can do that too, but I'll have you redo the essential skills first. You gonna be gone tomorrow? Okay. Anybody else? Anybody else is here? He's here. You here? Are you helping Jackie?
I believe I am.
Yeah. All right. Everybody else is good? All right. Oh man, I took it off.